Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2981. Find longest spatial substring that occurs thrice. It's a string based question and has been asked in Google 13 times in the last 6 months. So it's going to be a very important question if you are preparing for Google. Let's have a look on the problem statement. I will directly explain it to you using an example. Here what is given to us? A string. String which is having lowercase English letters and the length of the string is going only till 50. So this is given to us and what we have to return is length of longest spatial substring of S. Longest substring which is spatial. What is a spatial substring? A spatial string is having all the characters same. Okay, so we have to return the length of longest spatial substring of S. Any substring of S which is the longest and having all the characters same. Along with that substring is occurring at least thrice in that string. Okay, so return the length of the longest spatial substring of S which is occurring at least 3 times in the string. So let's say in this case, if I consider A as a substring, so A is occurring 4 times. If I considered AA as a substring, AA, okay, AA is occurring 3 times. And what about A and A? AAA. AAA is only 2 times. So AAA is a spatial substring but not occurring more than 3 times, more than or at least 3 times. So we are discarding it. This we can consider as a valid candidate. This is also acceptable, but yeah, this is not the longest. Longest is AA. So the answer is going to be the substring length. So length of the longest spatial substring is 2. So we are going to return true from this function. Okay, I hope you have understood the approach. It is pretty straightforward that you are given a string and you have to return the length of the longest substring which is having all the characters same, and that substring is occurring more than or at least 3 times. Let's have a look on this example as well. Here S is AB, AC, AD. First of all, I need to know like what are the spatial substrings in it. Spatial substrings are A is a spatial substring, B is that, A, C, A, D. All the substrings are of length 1. And A is occurring 3 times, B is occurring 1 time, C is occurring 1 time, D is occurring 1 time. So the longest spatial substring which is occurring at least 3 times, greater than or equal to 3 times, is A. So the answer would be length of it 1. So this is our problem statement. The problem statement is pretty straightforward. We don't have to do anything special in this. First of all, I will be capturing all the substring, and if that substring is occurring more than 3 times, so to capture the frequency, I need to capture the frequency of substring. Let's say substring is SS. I need to capture the frequency. Frequency is integer value and this is a string value. I can take a map of it. Map of string and integer to capture the frequency. Frequency map. And what is this string? This string is all the spatial substring. And spatial substring is that which is having only 1 character. So what I will be doing is I will be capturing frequency of all the spatial substrings of S. Let's take the same example. We have AAAA as our string, and I need to firstly get all the spatial substring. What is the logic of getting a substring? Substring is a piece of a string, or you can say subarray in an array, and those characters in the substring are contiguous. In short, just a piece of a string. So any slice of the string is like, let's say this AA is a substring, this AA is a substring, like this. I hope you already know this. Now I will have to capture all the spatial substring. Let's mark the indices 0, 1, 2, 3, and if I do the iteration on the string from 0, starting with 0, I will try to capture all the substring. Firstly, I captured this. This is a spatial one. Okay, capture it. A is coming 1 time in my map. This is my frequency map. And then I will increment the length if it is becoming special. So next character is same as the previous character. So AA is also valid. AA is also coming one time. AAA is also valid. And then 4 times A is also valid. AAAA one time. In this iteration, what I did is I captured or explored all the spatial substring starting with 0. And in the next iteration, I will do is I will capture all the spatial substring starting with 1. So starting with 1, I have 1, A. So A is incremented by 1. A is coming 2 times. AA is coming 2 times. AAA is coming 2 times. Okay. And then all the spatial substring starting with second index. A is coming 3 times. AAA is coming 3 times. And what about the last one? Last one is A. A is coming 4 times. So in the end, what is the state of my frequencies? 1, 2, 3, 4. So these are the final values. And among these final values, I need to return the length of the longest substring, spatial substring, which is occurring more than 3 times. So if any substring is occurring more than 3 times, I mean only these two are a valid candidate, and among these two candidates, whatever is having the maximum length, I will return that. Maximum length is 2. I can return that. So what I did is I did iteration from first for loop is from 0 to n-1, and second for loop or second loop is from j, and j is starting from I and going till n-1 until I keep getting a valid substring. In short, using nested loops, I am able to get all the substring. You can get all the substring in the n² time. Okay, and whenever you are getting a substring, so you will be capturing spatial substring frequency in the frequency map. And in the end, you just iterate over the spatial substring. And when you are iterating over the spatial substring, capture the length of maximum spatial substring. And when you do the iteration, just keep on track that the value should be greater than equal to 3. So nothing special in this, just playing with the iterations, 2 iterations on the string and 1 iteration of the hash map, and taking an extra data structure to store the frequency. So what is going to be this time and space complexity of this approach? Time complexity is we are capturing all the substrings, and capturing substrings are quadratic time, and then we are doing 1 iteration over the map. So overall it is going to be order of n into n². And same for the space complexity, because we are capturing, we have n² substrings, and all those n² substrings are being captured in the hash map. So overall it is going to be n² space, n² time, n² space. Now I will quickly code this approach. First of all, I will take a map to capture the frequency of every substring, and then I have taken some variables. Now I will iterate over the given string, and I will try to capture every spatial string starting from that specific index. For I equal to 0, I less than n, I plus plus, capture all the spatial substrings starting with I. As single character string is also a spatial substring, I will use a do while loop here. J is equal to 0, do something while j is less than n, and if it has reached, just ignore it. First instance is always a valid or spatial string, so I'm directly going to capture it. Map, firstly let me extract the spatial string. Spatial string is equal to s dot substring from index I to j. I have to pass +1 because it's a syntax. And then I will add the frequency in the map. Map dot put for substring ss, whatever is the value initially captured, just increment by 1. If that value is not already captured, get or default is 0. Okay, I have captured it. Now we have this in the frequency map. Now what I will do is I will see whether I can increment my j or not. I can only increment my j if j is less than n, and character at j is equal to character at j plus 1. S dot character at j is equal to s dot character at j plus 1. It should be j should be less than n minus 1. J plus 1 less than n, it means. So whether there is a scope of moving further, and we will move further only if the next character is equal to the current character. In that case I will increment my j. If I'm not able to increment my j, what I will do is I will just break the inner loop. There is no further spatial substring available, and until which we are able to get the spatial substring, we'll capture it in the map. And in the end, when we are coming out of this loop, we have captured all the spatial substrings along with their frequency. Now what I will do is I will iterate over the key set. Key set is having all the spatial substring, and now whatever substring is having frequency more than 3, I will try to capture the length of that maximum spatial substring. So if ss map.guessss spatial string is occurring more than 3 times, it means it is a valid candidate. So just capture the best candidate, and string ss maximum, let's say initially it is blank, this is the maximum candidate, and spatial string dot length is greater than ss max dot length. I have found a better substring. If I have a better substring, so I will update the substring. ss max is equal to ss max, ss substring maximum is equal to substring, and this substring is definitely have a frequency greater than 3, so there is no need to check the frequency, just check the size, whether we are able to capture the substring or not, because in the problem statement they are saying that if there is no spatial substring, then return -1. It means if ss max equal to empty string, in that case there is no candidate found, return -1, otherwise return ss max dot length. Let's test over sample test cases. Oops, something is broken. What it is saying, I to j plus 1. Here j should be initialized with I, because in every iteration we are checking spatial substring starting with I. So starting with I means j should start from I. Let me test again. This time it is passing all the test cases. I am submitting the problem. This is submitted successfully. I hope you have understood the approach, and the time complexity to this approach is n square. It worked fine because we are having very less constraints. S dot length is going till 50, and in the cases where S dot length is too much, in that case n square is going to give us TLE. N square won't be the optimized approach. So as a follow-up question, what you can do is you can check this question. Find longest spatial substring that occurs thrice, second part of it. In the second part of it, the constraint given to us is going till 5 into 10 to the power 5. In that case, this n square time is not going to work. We have to think of a better optimization. So try this question to practice further. So as a hint, if you look on this string with having AAA as a character, the whole string is itself is a spatial substring. So spatial substrings will be 4 times A, 3 times A, 2 times A, 1 time A. And this 4 times A is coming 1 time, then triple A will be 2 times, and this is 3 times, that is 4 times. Okay, so let's say as a next character, if you see that okay, there is another A, it means you are able to get a substring 5 times A. In this case, the frequency of the 5 times A will be 1, and frequency of all of these smaller number of values, like let's say 5 times A, then 4 times A, 3 times A, 2 times A, 1 time A, all will be incremented by 1, 2, 3, 4, 5, like this. So this is the hint, and now you can try that out, the second part of this problem. Thank you guys, bye bye.